Hello. In this lecture, I am going to discuss hydrolysis of salt formed by a weak acid and a strong base. Okay, let's get started. First, I'll give some examples for salt of weak acid and strong base. Okay, we have actually many examples. Sodium cyanide, potassium fluoride, sodium fluoride, okay, sodium acetate. Then we have actually many examples. Sodium sulfite, etc. etc. Many examples are there. Right? These are a few examples for salt of weak acid and strong base. Okay. Now what we are going to do, if you dissolve the salt in water, okay, what will happen to the pH of the solution? Will this salt undergo hydrolysis or not? Okay, all those things we are going to discuss in this lecture. Okay. So what I'm going to do, in general, I'll represent this salt as AB. Okay, I'll represent this salt as AB, where A is minus, B is plus. Okay, and you know very well, in the salt, A minus, that is anion comes from acid, and the cation comes from base. Okay, here acid is weak acid, okay, whereas base is strong base. Right? I have already told you that if a salt is made up of, if the salt is formed by a weak acid and strong base, okay, the stronger part decides the property of the solution, that is pH of the solution. Since base is stronger here, so pH of the solution should be greater than 7. Okay, this is the first point you should keep in mind. Okay, I'm going to represent in general the salt as A minus and B plus. Okay, now, now we'll discuss about how to find the pH of the solution and how to find the hydrolytic constant and what is degree of hydrolysis. Okay, everything we are going to discuss here. Okay, yeah. So let us take some amount of water in a beaker. Okay, and in this I'm going to add 1 mole of the salt AB. Okay, I'm going to add the salt, 1 mole of salt in water, so that you are going to get a solution. Suppose if the salt initially, right, at the beginning, the salt may not undergo any hydrolysis. So at the initial stage, the concentration of the salt, okay, in the solution, let it be C. Okay, so here C is concentration in molarity. Okay, we represent concentration in molarity. So this is concentration of the salt, okay, at the beginning of the dissolution. Okay, once you dissolve the salt, the concentration is C. Or let us assume that this is the concentration in salt before undergoing any hydrolysis. Okay, now what will happen? Once you dissolve it, what will happen? The solid, when you add in water, okay, you will get A minus aqueous ion and B plus aqueous ions. Okay, you will get ions. The salt, right, dissolves and produce ions. Okay, and in this, anion comes from acid, you know very well. Anion comes from acid and the cation comes from base. Right. Since the anion comes from weak acid, this ion must be a strong conjugate base. Okay, this ion must be a strong conjugate base, because it comes from weak acid. You know very well, weak acid produce stronger conjugate ions. Okay. Similarly, the base B plus, it comes from strong base. Therefore, the cation must be a weak conjugate acid. Acid will give conjugate base. Base will give conjugate acid. Weak acid will produce strong conjugate base. Strong base will produce weak conjugate acid. Okay, and I have discussed in the last lecture that uh, stronger conjugate ions, okay, will react with water. Therefore, hydrolysis will occur. Whereas weaker ions, right, weaker ions do not react with water. So hydrolysis, this salt undergoes hydrolysis because we have a strong conjugate ion in the solution, right? Yes, the salt undergoes hydrolysis, right? Yes, salt undergoes hydrolysis. Salt undergoes hydrolysis. It will undergo hydrolysis, no doubt in that, because we have a strong ion. Okay, how it will undergo hydrolysis? Let me discuss in the next one. See, this anion of the salt, since it is a strong conjugate base, it will react with the water, right? You can split water as H plus and OH minus. H plus will combine with this and form Ha. Okay, H plus combine with this and form Ha. Ha is a weak acid. Okay, and the remaining ion here is OH minus ion, right? That goes to the solution, right? And this reaction also occur in the reverse direction. So it is a reversible reaction, right? Now, what is the, so this reaction will attain equilibrium after few seconds or after few minutes, right? Then what is the equilibrium constant? Once it attains equilibrium, the equilibrium constant K can be given as equilibrium concentration of the weak acid into equilibrium concentration of the hydroxide ion divided by equilibrium concentration of the anion into equilibrium concentration of the water. Okay, but we are taking water as excess, therefore the change in concentration of water, right, is negligibly small. Therefore, you can assume this as a constant. Okay, this is a constant. So if I multiply this with this constant, I will get a new constant. Let me represent that as KH, where KH is called hydrolytic constant of the salt. Hydrolytic constant of the salt. Okay, so what is hydrolytic constant? It is nothing but equilibrium concentration of the weak acid times equilibrium concentration of the hydroxide ion divided by equilibrium concentration of the anion. Okay, let's take this as equation number 1. Right, now here we are getting a weak acid, and you know very well weak acid undergoes partial ionization. So let me write that equilibrium separately. So the weak acid in aqueous medium will undergo partial ionization and produce H plus ion, okay, and A minus ion, right? And this reaction, this dissociation also attain equilibrium, okay, and equilibrium constant for this equilibrium is represented as Ka. What is Ka? Dissociation constant of the weak acid or ionization constant of the weak acid. Okay, and Ka can be given as equilibrium concentration of the H plus ion into equilibrium concentration of the A minus ion divided by equilibrium concentration of the weak acid. Okay, I'll take this as equation number 2. Now, what I'm going to do, I'm going to multiply equation 1 and 2. So left hand side, we have to multiply separately, and right hand side, we have to multiply. So if I do that, what will happen? I'll get KH into Ka. KH into Ka is equal to So left hand side I am multiplying KH and KA, and in the right hand side, if I multiply these two, first I will write this term, equilibrium concentration of the weak acid into equilibrium concentration of the hydroxide ion divided by equilibrium concentration of the A minus ion into, and this part, equilibrium concentration of the H plus ion into equilibrium concentration of the A minus ion over equilibrium concentration of the weak acid. Okay, if I cancel the equal terms right in the numerator and denominator, see here A minus we can cancel, and you can cancel HA and HA. So what are the remaining terms we have? Okay, we have the product of H plus concentration in the solution into OH minus ion concentration in the solution. And you know very well this product of these two ions, concentration of these two ions is what we call as KW, ionic product of water. Okay, so what we get is KH into Ka is equal to product of H plus concentration, right, at equilibrium, and OH minus concentration at equilibrium, and this product is what we call as KW. KW, where KW is called ionic product of water. Ionic product of water. Okay, so from this we can calculate the value of KH. What is KH? KH is equal to ionic product of water, KW, divided by Ka. Right? Here, this KW value, Ka value, all depends on temperature. Okay, therefore, remember KH also depends on temperature. Okay, KW depends on temperature. Ka also depends on temperature. Therefore, KH also depends on temperature. Remember that, it's very, very important. Okay, now, so if you know the value of Kw at a given temperature and the value of Ka at the same temperature, then you divide these two values, you will get the value of Kh. Okay, Kh is nothing but hydrolytic constant of the salt. Okay, now the second goal is to determine degree of hydrolysis of the salt. Okay, where H is called, what is H? H is nothing but degree of hydrolysis. Degree of hydrolysis of the salt. Okay, right? So how to get this degree of hydrolysis? Very simple. I'll take this equation. There is the anion in the aqueous medium reacts with the water. Okay, form a weak acid HA aqueous and OH minus ion aqueous. Since this reaction produces hydroxide ion, okay, so the solution becomes basic, very simple. So pH should be greater than 7. Now, how to find the exact value of the pH? Okay, and how to find the value of degree of hydrolysis? So that's what we are going to do now. Now, what I'm going to do, see, initially we have taken 1 mole, right? See, we have taken 1 mole. Initially, we have taken 1 mole of the salt. Okay, so if I add 1 mole of salt in water, I will get 1 mole of, or 1 mole of salt will give, okay, I will discuss like this. 1 mole of salt, when you add, you will get 1 mole of the A minus ion and 1 mole of the B plus ion. Correct? Because one molecule, if it dissociates, you will get 1 anion, 1 cation. Therefore, 1 mole will give 1 mole of anion, 1 mole of cation in solution. Okay, so we have 1 mole of A minus ion initially. Initially, we have 1 mole. Okay, at the initial stage, there is no water remains same. Okay, there is no aqueous, there is no acid, there is no OH minus at the beginning. Okay, or at time 0. At time 0 means hydrolysis does not occur. Now, once the time attains the equilibrium time, Okay, once the reaction at an equilibrium, what will happen? From this 1 mole, okay, let us say H mole, okay, H mole dissociate, where H is the degree of hydrolysis of the salt. Okay, from 1 mole, let us assume that H mole reacts. If H mole react, see if one ion react with water, I will get 1 HA molecule, 1 OH minus ion. So if H mole reacts, what will get? We'll get H moles of HA and H moles of OH minus. Right? What is the concentration? Equilibrium concentration? Equilibrium concentration. You know very well, if the 1 mole remains as such, 1 mole of the salt, if it does not undergo hydrolysis, concentration is C. But it undergoes hydrolysis, therefore at equilibrium, we have only 1 minus H mole of A minus ion. Therefore, concentration of A minus ion at equilibrium is 1 minus H into C. Right? If all A minus remains as what remains, if it does not undergo any hydrolysis, then you will be having 1 mole of A minus ion. For 1 mole of A minus ion, concentration is C. But due to hydrolysis, okay, from 1 mole, H mole is dissociated, reacted. So the remaining mole is only 1 minus H. Right? If 1 mole concentration is C, then 1 minus H mole concentration is 1 minus H into C, simple. Similarly, we are getting H mole of HA, therefore equilibrium concentration is HC, and here equilibrium concentration is HC. Okay, therefore I can write hydrolytic constant, okay, as, let me write the next page. So hydrolytic constant KH equal to equilibrium concentration of the acid into equilibrium concentration of the OH minus ion divided by equilibrium concentration of A minus ion. Right? Or I can say, right, KH equal to, what is the equilibrium concentration of acid? H into C. What is the equilibrium concentration of the hydroxide ion? H into C. And what is the equilibrium concentration of the A minus ion? 1 minus H into C. Right? If I cancel this C and C, we get KH is equal to H square C by 1 minus H. Okay, this is the relation between, okay, relationship between hydrolytic constant and degree of hydrolysis H. Right? Suppose if H is less than 0.1, okay, if H value is less than 0.1, right, in that case 1 minus H is roughly equal to 1. Okay, if 1 minus H is roughly equal to 1, then I can write KH equal to H square C by 1, or you can write H square equal to KH by C, or H is equal to square root of KH by C. Okay, so if you know the hydrolytic constant and if you know the concentration of the salt, okay, and the initial concentration of the salt, right, you can calculate the degree of hydrolysis of the salt. Remember, KH depends on temperature, therefore degree of hydrolysis also depends on temperature. Okay, now I will see how to calculate pH of the solution. Right, how to calculate pH of the solution. Right, how to calculate pH of this solution. This is the next point. Right, you know very well the equilibrium concentration of hydroxide ion in this case is H into C. Okay, so hydroxide ion concentration is available. Okay, and we can also write this as, so what is so hydroxide ion concentration at equilibrium equal to, right, what is the relation for H? H is equal to square root of KH by C into C. Okay, I am assuming H is small. Okay, I am assuming H is small. If H is less than 0.1, right, then H can be written as square root of KH by C. Right? Yeah, for most of these salts, okay, H value will be less than 0.1 only. Right? Now, if I bring the C inside, I'll get square root of KH into C. Okay, when you bring C inside the square root, it becomes C square. So C and C square, if you cancel, you get C. Right? And you know very well, KH is nothing but KW by KA into C. So this is the expression for OH minus. Now what is the formula for POH? You know very well, POH equal to negative log of base 10 concentration of hydroxide ion. Okay, this is the formula for POH. POH equal to negative log of concentration of OH minus ion. Okay, and OH minus ion concentration is available minus log base 10. So what's the value? Kw into C by Ka whole power half. Square root you can write as whole power half. Bring this 1 by 2 in front, logarithmic formula. So minus 1 by 2 into log base 10. I can separate this as C. You can write this as A into B by C. A into B by C can be separated as log A plus log B minus log C. Okay, A and B are in the numerator, so I'll write as plus plus, and C Ka is in the denominator, so I'll put minus. Okay, now if I fix temperature as 25 degrees Celsius, at 25 degrees Celsius, the value of Kw is 10 power minus 14, right? Therefore, POH is equal to minus 1 by 2 into log base 10 power minus 14 plus log C base 10. Negative logarithm of Ka is nothing but pKa. Negative logarithm of Ka is nothing but pKa. Okay, and bring this minus 14 in front. Okay, if you bring minus 14 in front, I'll get log 10 and base 10. Log 10 base 10 value is 1, therefore you get minus 14 here. And if I multiply by minus 1 by 2, okay, minus 14 into minus 1 by 2, I'll get 7. Okay, let me write the next one. So POH equal to 7. Right? See, if you bring minus 14 in front, you'll get minus 14 into log 10 base 10. Log 10 base 10 is 1, so you'll get minus 14 here. If you multiply by minus 1 by 2, minus into minus become plus. 1 by 2 into 14, you'll get 7. Okay, then minus 1 by 2, I'll multiply here. So what will I get is 7 minus 1 by 2 into log C base 10 plus pK. Right? This is POH. What we want is pH. You know very well. pH plus POH, okay, equal to 14 at 25 degrees Celsius. Right? Therefore, pH is equal to 14 minus POH. And this is the POH we have. So 14 minus of this. So I'll get minus 7 and minus become plus 1 by 2 log C base 10 plus pKa. Right? 14 minus 7 is 7. So 7 plus 1 by 2 into log C base 10 plus pKa. This is the formula for pH. So if you know the concentration of the salt, right, at the beginning, okay, this, see, we are adding, we are going to prepare the solution. So if we add 1 mole of salt and if we prepare a solution of 1 liter, yes, you can find the concentration directly. So if you know the number of moles of the salt present in a given volume of solution, you can find the concentration. And if you pKa value for many weak acids are already available at different temperatures. Okay, at 25 degrees Celsius, these values are already available. So if you know this value and this value, yes, you can calculate the pH of the solution, right? Solution which contain the salt of weak acid and strong base. Okay, yeah. So remember all these informations, right? In the next class, we will discuss how to get the expression for pH of salt which undergoes hydrolysis, pH of salt formed by strong acid and weak base when it undergoes hydrolysis. Okay, yeah, I stop here. Thank you for listening.